Now, more about the p block elements. The anomalous properties of nitrogen are there. Nitrogen is not having the availability of d block orbitals. So, as it is not having the availability of d block orbitals, it is having a unique ability to form p pi bonding only. As it is having the ability to form p pi bonding, it is having the multiple bonding by involving only p orbitals. This is because of its small size and high electronegativity. The heavy elements of this group, which have the d orbitals present in them, they form d pi p pi bonding, but nitrogen only form p pi. The other elements of nitrogen group or group 15 do not form p pi due to the availability of d orbitals. Nitrogen exists as diatomic molecules, as already been discussed. Here also we are observing that nitrogen is not existing in N single bond because of its instability and small size and high electronegativity. This is the reason it is having high bond enthalpy. But on the other hand, the other element like phosphorus, arsenic, antimony and bismuth all are able to form stable single bond, and their dissociation enthalpy is slightly less. N single bond is very weak because of its small size and interelectronic repulsion, which make the bond very weak due to the non-bonding electrons, and this is a reason the catenation tendency in nitrogen also is slightly less than phosphorus. Phosphorus is having slightly higher catenation tendency because of its stable p bond, single bond, and high bond dissociation enthalpy. So here other elements are forming p pi d pi bonding. Why they are able to form p pi d pi bonding? Because other elements in this group is having the availability of d orbitals. So other elements are also forming some organic compounds also with alkyl group, and phosphorus, arsenic can form d pi p pi bonding. With the help of it, they are able to form the organic compound also. Arsenic and phosphorus also act as a ligand in organic chemistry because of the involvement of d orbitals. So here now let us discuss few more compounds of group 15. The very first compound of group 15 is with hydrogen. They are also known as hydrides. The general formula of hydride is EH3. So as the general formula of hydride is EH3, so E can be replaced by nitrogen, phosphorus, antimony and bismuth, and they all are known as hydrides. NH3 ammonia, PH3 phosphine, ASH3 arsine, SBH3 stibine, BiH3 bismuthine. Now coming to more about them. The stability of hydrides decreases from ammonia to bismuth. Why the stability decreases from ammonia to bismuth? Due to decrease in the electronegativity, the bond dissociation enthalpy decreases. As bond dissociation enthalpy decreases due to increase in size, that is why the hydride stability decreases. Now more about hydrides is that hydrides stability down the group decreases. Why it decreases? Because of decrease in bond dissociation enthalpy, and bond dissociation enthalpy decreases due to increase in size, increase in bond length. It is easy to break the bond. The next thing about hydride is their reducing character. The reducing character of hydrides increasing down the group. Why it increases down the group? The next arises as down the group the size increases, so ability to lose electron of the central atom is also increasing. So ability to lose the lone pair in the hydrides is also been increasing. So that is why the reducing character down the group of hydrides increases. Now coming to the ammonia. Ammonia is a mild reducing agent, while bismuthine is a strong reducing agent because of its size. So here the next thing and the last property is basicity. Basicity means ability to share the electrons. So this ability to share the electron down the group decreases. The reason is very simple. Why the ability down to share the electron of this lone pair which is present on the central atom decreases due to increase in size. So as due to increase in size, the centralized lone pairs present on the central atom, their electronegativity decreases and their availability also decreases down the group. This is a reason the basic character down the group of hydrides decreases. So basic character down the group decreases, then bond dissociation enthalpy decreases, that decreases their stability, and now reducing character increases. The next compound which we are going to discuss today is reactivity towards oxygen. So here the reactivity towards oxygen is in two oxidation state, +3 and +5. In +3 the formula is E2O3, and in +5 the formula is E2O5. So there are two oxides present in group 15. One is having formula E2O3 and second one is E2O5. Definitely the higher oxidation state will be more acidic and than the lower oxidation state. It means the formula E2O5 is more acidic in nature and E2O3 is less acidic. The oxides of E2O3 of nitrogen and phosphorus are purely acidic. Why they are purely acidic? Because of their higher electronegativity, but the acidic character of oxides of group 15, the general formula is E2O5 and E2O3. E2O5 will be more acidic than E2O3. So here the acidic behavior of E2O3 down the group decreases. Reason? Increase in size. The same stands for E2O5 also, that down the group E2O5 acidic behavior will decrease. Means N2O5 will be more acidic than P2O5 or AS2O5. In the same manner, N2O3 will be more acidic than AS2O3. So here, but as we move down the group, the acidic behavior decreases and basic increases. Arsenic and antimony oxides, whether in +3 oxidation state or +5 oxidation state, will be amphoteric, while bismuth in both the cases will be basic. Now coming to the next compound of group 15, that is halogen. Halogen is also having the two general formula EX3 and EX5. It means in +3 oxidation state and +5 oxidation state. Nitrogen is the only element which do not form any pentahalide, reason due to non-availability of d orbitals in its valence shell. So the maximum ability of nitrogen to form a bond is 4. So NF3 is known to be stable in +5 oxidation state. Nitrogen do not form any halides, and this character, ionic character, down the group increases, and as down the group increases, increase in size. And when we talk about trihalides, from nitrogen to bismuth, the covalent character down the group decreases, but bismuth for fluoride is the only halogen which is covalent in nature because of the higher electronegativity of fluorine. Reaction towards metal. All group 15 elements reacts with metal to form binary compounds in -3 oxidation state, Ca3N2, Ca3P2, which are mostly ionic. So in -3 oxidation state, all group 15 elements form compound with metals. Question: nitrogen exhibit +5 oxidation state, but it do not form any pentahalide. Reason: nitrogen has electron in s and p orbital only. It do not have any d orbital to expand its oxidation state. That is why it do not form pentahalides. pH3 has lower boiling point because phosphine do not form any hydrogen bonding, while ammonia forms, which increases the boiling point. And this is an exception, that ammonia should have lower boiling point, but it is having higher because of hydrogen bond. Now coming to the next compound of nitrogen is dinitrogen. So dinitrogen is N2, which is commercially being prepared by the liquefaction of air or distillation of air. So here the nitrogen can very easily be prepared by air, and here in laboratory nitrogen is being prepared from ammonium chloride. So from ammonium chloride, dinitrogen can be prepared, and the very simple preparation is ammonium chloride with sodium nitrate. When reacts, it gives dinitrogen in lab along with water and NaCl. Small amounts of NO and HNO3 is also being formed, which can be removed as an impurities by passing gas through the aqueous sulfuric acid containing potassium dichromate. It can also be obtained by thermal decomposition. Next preparation is very easy. Thermal decomposition of ammonium dichromate also gives dinitrogen prepared in the lab, and the very pure nitrogen can be obtained by barium nitride heating. Barium nitride simple thermal decomposition gives barium and dinitrogen. Now coming to the properties of dinitrogen, it is a colorless, odorless, tasteless, non-toxic gas, and two simple isotopes exist, N15 and N14. It has low solubility in water because N2 bond is very stable, and freezing and boiling point is given in the table below. Nitrogen is rather inert at room temperature. Now, why it is inert at room temperature? Because nitrogen exists in N2 form having triple covalent bond, which gives extra stability, and high bond dissociation enthalpy, which gives a inert behavior. At a very high temperature only, it directly combines with metal to form ionic nitrides, and with non-metal it forms covalent nitrides. The reactions are here, that lithium with nitrogen form lithium nitride, magnesium with nitrogen form magnesium nitride. It combines with hydrogen to give ammonia, that gives the reaction with nonmetals, and with oxygen to form various oxides. The main uses of nitrogen is in the manufacture of ammonia and other industrial chemicals, calcium cyanamide, as you can say, is fertilizer also, and it is being obtained from inert to maintain an inert atmosphere in metallurgy. And liquid dinitrogen is also used as refrigerant, which is a very important use, that be it preserve biological material, food items, and in cryosurgery is also dinitrogen is being used.